So today we're going to learn how to factor polynomials and trinomials as well as their special cases. And we're also going to go over the steps that we take to solve them. So first step is look for common factors. Second, we're going to look for special cases. Third, we're going to do our best to use factor pairs. And fourth, if there are four terms, we're going to try factoring by grouping. So when we look for common factors, we're going to look at the two terms of a polynomial and see what they have in common. As we can see here, our polynomial is u cubed v plus uv cubed. Now, if we think about what we have in common here, uv is the common factor, so we're going to pull uv out of the polynomial, which will give us uv parenthesis u squared plus v squared. Because when we pull uv, this first term is going to lose its v and it's going to lose one of its u's, giving us u squared. When we pull uv from this equation, or from this term, it's going to pull the one u out of it and then pull one of the v's away, which gives us v squared. So our factored polynomial will be uv parenthesis u squared plus v squared. Now for the next example, instead of using two variables, we'll have just one with more constants and coefficients. So we have 2x cubed plus 2x squared minus 6 is our polynomial. And if we think about what's common in these, all of these you could pull 2x out of. So when we pull 2x out, we will get 2x parenthesis x squared plus x minus 3. Because when we pull 2x from 2x cubed, we're just going to have x squared because it's going to lose the 2 and lose one of the x's. When we pull 2x away from 2x squared, it's just going to be x because it loses the 2 and one of the x's. When we pull 2x from negative 6x, we're going to end up with 3 because we're pulling away the 1x and we're dividing the negative 6 by 2, which gives us negative 3. So for our second step, we're going to look for special cases that apply to our polynomial. So the first special case we'll be looking at is factoring the difference of two squares. Now, the difference of two squares, for example, would be right here, u squared minus v squared. Now, if we look at our polynomial in this example, we have 4x squared minus y plus 3 squared. If we think about it, because of these two exponents, we can see that basically in this case, our u is 4x and our y plus 3 is our v. So the way we can rewrite this into this format is by changing 4x squared into 2x squared and then just leaving the y plus 3 squared as is. Then we'll start by putting it into this format. We know that 4x is our u and y plus 3 is our v, so we'll plug in 2x plus y plus 3 and then 2x minus y plus 3 because we have u plus v, u minus v here. And then we're going to just go ahead and remove our brackets to simplify, and since we have a minus sign here, that's going to apply in here as well. So we'll have 2x plus y plus 3 times 2x minus y minus 3 for our fully factored example. So we're still here in step 2 where we're looking for special cases, and in this instance we're going to be factoring perfect square trinomials. So this is factoring for the sum of perfect squares, and our sort of format for this is going to be u squared plus 2uv plus v squared. But before you do this, you need to look at your polynomial and make sure that it's going to fit into this format where you can break up your middle term into 2uv in order for it to be a perfect square trinomial. So when we look at this polynomial, we can see that in this instance our u is going to be 3x. So what we're going to do is we're going to break down 9x squared into 3x squared, and that'll give us 9x squared, so it doesn't change at all. Our v is going to be 1, so we're going to take our middle term, which is 6x, and break that up into 3x times 1, because that fits this format here. And then we already know our v is equal to 1, so we're just going to have plus 1 squared on the end here. And when we simplify all of this, we're going to just take 3x plus 1 squared to put it into this format down here because we know our u is 3x and our v is 1. We're just putting that in parentheses and squaring it. So our third special case that we're going to be looking at when we're factoring polynomials is going to be the difference of perfect squares. So the way you're going to know whether it's a difference of perfect squares or a sum of perfect squares is the first term in the equation. We can see our first sign here is a negative, so we know we're going to have a difference of perfect squares. So when we look at our equation, we have 4x squared minus 12xy plus 9y squared. And when we plug it into our formula up here, we can see that our u is 2x and our v is 3y. So what we're just going to do is we're going to take this and plug it into our formula. So 4x squared is going to change into 2x squared. Our middle term of negative 12xy is going to change into negative 2 parentheses 2x parentheses 3y. And then our final term of 9y squared is just going to turn into 3y squared. And then when we simplify all of this at the end, we will end up with 2x minus 3y squared for our result. So for our next special case, we'll be looking at factoring the sum and difference of two cubes. And in this instance, we will be factoring the sum of two cubes. So the two cubes in our formula will be u cubed plus v cubed. And when we look at our polynomial right here, we can see that our u is going to be 8x and our v is going to be 27, but v is cubed, so our v is actually going to be 3 because 3 cubed is 27. So when we go to simplify this, we'll change 8x into 2x cubed, which is the same value as 8x cubed, and then we'll be changing 27 into 3 cubed. And then once we have it factored in this form, we're going to go on further to simplify it. And when we look here, we'll simplify it into 2x plus 3 and 4x squared minus x plus 9. So the next special case we'll be looking at is factoring the difference of two cubes. And the way that we're going to know that our polynomial is a difference of cubes is we have a minus sign instead of a plus. So when we look at our polynomial right here, we can see that we have two cubes, x cubed, and then we have 64, which is 4 cubed. Now if we look at this format, we can break 64 down into 4 cubed just like this, and now we have an x cubed minus 4 cubed, so our u is x and our v is 4. And when we look at this formula, we'll just have u, which is x, minus v, which is 4, x minus 4. Then we have u squared, which is x, so we have x squared. Then we have uv, which is 4x. And then we have negative v squared, which gives us negative 16. So our result is x minus 4 times x squared plus 4x minus 16. So for our third objective, we're going to be using factor pairs. And in this case, our polynomial is going to have a leading coefficient of 1. So we can see that our first term is x squared, so we're just going to go ahead and break that up by having parentheses with an x inside and parentheses with an x inside, because when those get multiplied, that will give us an x squared. Now, what we're going to do to factor this further is we're going to find two numbers. First, we're going to find two numbers that add up to 5, but we also want them to multiply to negative 14. So when we think about that, two numbers that add up to 5 would be negative 2 and 7. And then when we multiply negative 2 by 7, we get negative 14. So we will simply just end up having negative 2 and 7 in the parentheses. And when we FOIL this out, we'll end up with our parent equation of x squared plus 5x minus 14. It's always good to go ahead and FOIL the factored equation out to make sure you get what you started with and you did it correctly. So still using factor pairs, we're going to solve an example that doesn't have a leading coefficient of 1. And the way we're going to deal with this is we're going to split up the leading coefficient just like we did in the first one. But since we can't just split it up into x squared because we have that 35 there, we're just going to split up 35 as well. So 5x times 7x will give you 35x squared. And then we're going to do exactly what we did in our last example, where we found two numbers that multiplied to negative 12 but added up to negative 1. So, because that's our middle coefficient and then our constant. So, two numbers that add up to negative 1 but multiply to negative 12 would be 3 and negative 4. So the way that we would end up writing this out is 5x and 7x, which we had from splitting 35x squared into two pieces, and then we'll just have plus 3 in one and minus 4 in the other. Alright, so for our fourth objective, we're going to be factoring by grouping, and that's if we have 4 or more terms in our polynomial. So basically what we're going to start by doing is just breaking up our polynomial into two separate groups. So here we'll just be putting 3x cubed plus x squared in a group minus 6x squared plus 2, because we're basically just pulling the parenthesis away from that, and that'll turn into a positive. And then we'll just start by factoring the individual sides. So we'll pull an x squared out of this side, and we'll end up just having 3x and then plus 1. And then over here, we're going to pull negative 2 out. So we're going to end up with 3x plus 1. And then finally, we'll take these two outside, since we have these two outside terms and then these two inside groups are the same, we're just going to take the inside group, 3x plus 1, and then multiply it by the outside group, which is x squared minus 2. And then if you FOIL that out, you get what you started with.